Jeremy, and welcome to Snap Science Tutorial. Today, I will tackle about the origin of the universe. You have probably heard the term Big Bang when people start to talk about the origin of the universe. But when people tell you that the universe started really small, tinier than a grain of sand, things become a little more difficult to grasp. The theory of a Big Bang is the most widely accepted hypothesis for the origin of the universe, but it still leaves many questions unanswered. I will show you a video regarding the application of Big Bang theory by using a balloon. The most popular theory of universe origin centers on a cosmic cataclysm unmatched in all of history, the Big Bang. This theory was born of the observation that other galaxies are moving away from our own at great speed in all directions as if they had all been propelled by an ancient explosive force. The first scientist to come up with the idea of Big Bang was the astrophysicist Friedrich Franz Friedmann, who used relativity field equations to prove that the universe is expanding. Edwin Hubble's observations later proved this theory. Hubble discovered the redshift of galaxies. He measured their distances from Earth by observing variable stars called Cepheid. The redshift distance law of galaxies is now referred to as Hubble's law. The discovery of cosmic microwave background radiation in 1965 made the Big Bang theory the best theory of the origin and evolution of the universe. Radio astronomers Arno Penzias and Robert Wilson discovered the cosmic microwave background radiation, which is thought to be left over from the initial explosion of matter. According to the Big Bang theory, the solar system was formed from a cloud of space dust and gas that was squeezed by a supernova explosion. As the nebula contracted, it spun increasingly rapidly, leading to frequent collisions between dust grains. Gravity pulled the gas and dust together, forming a solar nebula. This solar nebula grew hotter and denser, forming a disk of gas in its center. Particles of nebula dusty started to stick together, forming clumps that eventually formed planets and their satellites. Eventually, the hot center of the solar nebula formed a star, the Sun. Different planetary particles left over from this initial explosion can still be found flying around in space. These particles are called meteorites. By studying these meteorites, scientists have found that our solar system is about 4,600 years old. Like all scientific theories, the Big Bang theory has its pros and cons. For example, the cosmic microwave background radiation, which is the main proof of Big Bang theory, comes from widely separated parts of the sky. These regions are too far from each other to be able to interact with each other, with signals traveling at the speed of light. But according to the smooth background radiation, whose sources have similar properties, they must have interacted with each other. This problem is referred to as the horizon problem. Another problem with the Big Bang is the flatness problem. The experimental evidence is that the present universe has very low geometrical curvature in its space-time. In other words, it is flat. According to the Big Bang theory, the universe expands, but unless this expansion is confined to an incredibly narrow range of possibilities, it would not have stayed flat. Alan Guth formulated the inflation theory. It states that 10 raised to 50 expansion rate and 10 raised to 32 seconds, and Lindy estimated 10 raised to 1000 increase in size. Since the universe expanding and accelerating objects are being dug out of Earth's Hubble volume and will become undetectable to humans of the future. The Hubble volume is more than 13.8 billion light years in radius, because the expansion of space has increased distances between objects faster than light can travel. Astronomers have three assumptions about the universe based on theory and observation. The laws of physics are universal and don't change with time or location in space. The universe is homogeneous or roughly the same in every direction, and humans do not observe the universe from a privileged location, such as its very center. When these assumptions are applied to Albert Einstein's equations, they indicate that the universe has these properties. The universe expands and the universe emerged from a hot dense state at some finite time in the past, and the lightest elements, hydrogen and helium, were created in the first moments of time. A background of microwave radiation fills the entire universe, a relic of the phase transition that occurred when the hot early universe cooled enough for atoms to form. One alternative theory is the steady-state theory, posits continuous creation of matter throughout the universe to explain its apparent expansion. This type of universe would be infinite with no beginning or end. The oscillating model of the universe involved an endless series of Big Bangs, followed by big crunches that restarted the cycle endlessly. Applications found in quantum gravity and string theory tantalizingly suggest a universe that is in reality nothing like how it appears to human observers. That's all for today. Keep on watching Snap Science Tutorial and kindly visit our website at www.snapsciencetutorial.com. I hope you learned a lot. Thank you and God bless.